So you'll remember from last year that the chain rule applies to functions that are nested. So f of g of x. Does anybody remember what we call those kind of functions when you have an outside function on the outside and then something else on the inside? It has a word name.
Right here.
Give you some clues. No, still not. It's called the composite function. Okay, composite function is where you have f of g of. Now that could go f of g of h of. It could just keep going on and on. When you have a composite function, it's one kind of function on the outside, maybe a square root, and then another kind of function on the inside, maybe a log, and then another kind of function. It just keeps all different. Those are called composite functions. So if you have a composite function, then the chain rule says that dy dx. All right, which derivative do you do first? The outside. So f prime first. Or let's write it with Leibniz. Let's do df dx on the outside, where g of x is left by itself, left alone, times, okay, then which one comes next? dg dx with x left by itself, and then finally at the end, x prime, or we're going to do dx. Okay, so all of those, the chain rule, nesting them all outside first, leave the inside by itself, then the next outside, leave the inside by itself, and then finally the last one. So it also works with increasingly large functions. So if you have a composite that's f of g of h of j of x, so 1, 2, 3, 4, right? 1, 2, 3, 1, 2, 3, 4. All right, there we go. Okay, so you could have the square root of a logarithm of a sine of an exponential. Okay, all those, and then a polynomial worked in there too, all the different ones. Okay, so let's do Newton's way then. So then y prime in Newton's notation would be f prime on the outside with g of h of j of x all on the inside. 1, 2, 3, 4 times then g prime with h of j of x, 1, 2, 3, then h prime of j of x, and then j prime of x, and then finally x prime. So it's possible, no matter how long the composite function is, you just keep, that's what the chain rule is, another link in the chain, another link in the chain, another link in the chain. So I just want to review with you how to do a couple of these problems, and then you can get started on the homework for the weekend. So our first example is going to be a nested function or composite function. So given, let's do y equals the sine of 1 plus the tangent of 3x. Okay, boy, you want to try that one? So let's do find y prime. All right, he's ready. Y prime equals cosine, he says. 1 plus tangent of 3x, okay, times secant squared of 3x, good. Oops, I did. And then finally times the chain rule on 3. Okay, good. Now the order in a multiplication is irrelevant. Typically we will put the coefficient of 3 in the front because it's a constant, and then probably the higher power of secant squared of 3x would come next, and then the lower power of cosine of 1 plus tangent of 3x would come last. But we're not going to be super picky about the order that you do that in. Okay, one more, just to refresh our memories on how the chain rule works. So how about y equals the cosecant squared of 5x cubed minus 2? All right, what do you think about that one? The square is first, because really cosecant squared of 5x cubed means cosecant of 5x to the third minus 2, that whole thing squared. So the squared is actually what comes first, not the cosecant. And so y prime would equal, and then we'd have to deal with the square first. Okay, Trong, you want to try that one? All right, do the outside first. So 2, and then we're going to leave the inside totally alone. So cosecant of 5x cubed minus 2, that whole thing is now to the first power. So all we've done is deal with the square. All right, the next link in the chain will deal with, okay, so now we got to remember what the derivative of cosecant is. Cosecant cotangent, but it's also negative, right? So we want times negative cosecant of 5x cubed minus 2 and cotangent of 5x cubed minus 2. All right, times, good, now it's 15x squared. So if we're going to put all of that in order, what would the leading term of that be? Looking at all the constants and coefficients. Negative 30 is going to come first. That's the negative and the 2 and the 15. And then you're going to have the x squared. And then what would come after that? What's going to be the leading power on that one? Yeah, there's 2 cosecants. So let's write it as cosecant squared of 5x to the third minus 2. And then finally at the end we'll trail off with the cotangent of 5x cubed minus 2. So I think that's enough of review of the chain rule, and then you can use your AP study hall to get started.